We continue our discussion with derivative under integral sign, the Leibniz rule. Solve this integral 0 to a log 1 plus ax divided by 1 plus x square log x. F of a is equal to, and hence evaluate f of 1. Okay, let me write down the solution. Basically, it involves first step to find out f dash of a using derivative under integral sign. Then simplify it, and there will be one integration term which is remaining, the partial derivative one. Integrate, and for that you need to use partial fractions for integrating. Then you will end up getting f dash of a, simplify f dash of a, and then integrate to get f of a. Find value of c, substitute 1 to get the answer. That is the roadmap. So let me straight away write down the solution. F dash of a is equal to integral 0 to a partial derivative of the first term, which is x upon 1 plus ax into 1 plus x square dx, plus when the upper limit is non-zero, I mean it's a function, therefore derivative of upper limit is 1 into, substitute wherever you have x, you should substitute the parameter, and therefore you end up getting log 1 plus a square divided by 1 plus a square. Okay. Now, still this integral needs to be evaluated. You have two terms in the denominator in the factorized form. Degree of denominator is 3, degree of numerator is 1. So you need to figure out what are the partial fractions. But because I know the partial fractions, this gets factorized or split as a upon 1 plus a square into 1 plus ax plus x plus a upon 1 plus a square into 1 plus x square. This is the split of this, and therefore you are supposed to integrate this 0 to a dx, integral of this to a dx plus the last term as it is. This term will continue till you finish the integration. Okay. Therefore, this is equal to 1 upon 1 plus a square inside bracket log 1 plus ax to be evaluated between 0 to a plus absolute value of 1 upon 2 into 1 plus a square log 1 plus x square to be evaluated from 0 to a plus a tan inverse x upon 1 plus a square to be evaluated from 0 to a. That is what it is, and therefore we end up getting minus 1 upon 2 into 1 plus a square log 1 plus a square plus a upon 1 plus a square tan inverse a and therefore dash of A is, now this term and this term is same, this term and this term is same, therefore I mean this is 1 minus half. If you understand, 1 minus half makes it plus 1. That is what is the final correct answer for f dash of A. Okay, therefore we need to integrate now. F of A is equal to. Now you have two functions here. 1 upon 1 plus a square is one function, and a log 1 plus a square is another function. LIATE. So first function will be your log function, and therefore using integration by parts to this, you will get the integral of f of a as half inside bracket tan inverse a log 1 plus a square minus integral 2a upon 1 plus a square tan inverse a dA. This is the first part of the story, and plus integral a upon 1 plus a square tan inverse a b plus c. That is the second part of the story. Okay, 56%. Therefore, this implies f of a is equal to half tan inverse a log 1 plus a square plus c. Now if we substitute a is equal to 0 in the given problem, then f of 0, capital F of 0 is 0. Capital F of 0 is equal to 0 because lower limit is also 0. So if we substitute f of 0 in this case, which is 0, is equal to tan inverse 0 and log 1, everybody is 0, therefore c is equal to 0. And hence our function is without this. Now you are supposed to put value of 1, I mean f of 1. So f of 1 is equal to half tan inverse 1 is pi by 4 log 1 plus 1 square is 2. Hence answer is pi by 8 log. That is the complete story. This problem requires almost everything. Integration by parts, integration by partial fractions, derivative under integration, etc. Questions? Next problem, f of alpha is equal to integral 0 to infinity e raised to minus x square cos alpha x dx. Find simple form of f of alpha if f of 0 is equal to root pi by 2. We will see how it is root pi by 2. We will find out a little later. So presently I give you f of 0 is root pi by 2. Correction. 9. What was it? Capital F of alpha yes, again this is similar. So f dash of alpha is equal to minus integral 0 to infinity sin alpha x. What is important here is this function you are supposed to differentiate with respect to alpha. That is what is being written here. That is your f dash of alpha. Okay, minus sign taken out. Now we need to deal with this integral. Therefore, this is integration by parts. Okay, and in which u into integral. So this is u and this is v, because antiderivative of x e raised to minus x square is easy, and therefore u into v, you end up getting first term as half sine alpha x into e raised to minus x square to be evaluated between 0 to infinity minus alpha by 2 integral 0 to infinity e raised to minus x square cos alpha x dx. Now this is important because this is original function. If you substitute these values back into this equation, minus x square, when you put x is equal to infinity, it becomes 0. And when you put a 0 over here, it becomes 0. Therefore, the first part of the f dash of alpha is 0, and hence you end up getting minus alpha by 2 f of alpha. So you take it to the other side. This is little variable separable type differential equation, but it is not difficult. We will learn it. Taking integral of both sides, you get log f of alpha is equal to minus alpha square by 4 plus constant of integration, which you can always take it in terms of log, plus c1, and therefore I can write f of alpha as minus 1 by 4, sorry, f of alpha as constant times e raised to minus 1 by 4 alpha square. Now we have been given f of 0 is equal to root pi by 2. So by putting the value of alpha is equal to 0, we get c is equal to root pi by 2. Put alpha is equal to 0, c is equal to root pi by 2, and therefore your final f of alpha is equal to root pi by 2 e raised to minus 1 by 4 alpha square. Okay, this is what it is. Any questions? Now let me give you some easy problems. Problem number 3. Capital F of x is equal to integral x square to x cube log p square plus 1 dt. Now, when this function is independent of x, partial derivative term is absent. So this is very fast. Get me the answer. Find f dash of x. Substitute upper limit first, which is log x raised to 6 plus 1 multiplied by differentiation of x cube, which is 3x square minus log x 4 plus 1 into derivative of x square. That is the answer. Easy. I should have given it in the beginning. Anyway, 4. Problem number 4. It should not be that easy. G of x is equal to integral 0 to x t square integral 1 to t f of u du bracket complete dt f of 1 is equal to 3, sorry, f of 1 is equal to 3, find, now this f and that f is same, f of x is equal to 1, f of 1 is equal to 3, find g dash of 1 and g double dash of 1. Okay, g of x is given, so our parameter is x and variable is t. And if you observe this function, we don't have any x in it. So when we differentiate this with respect to x, it is going to be 0 because it's a constant for us as far as x is concerned. Therefore, first integral term in derivative under integration is 0. Second is differentiate. Second term is f of this. Wherever you find t, you put x. Therefore, a g dash of x is equal to x square integral 1 to x f of u du into derivative of x, which is 1. That's all. And second term, because this is 0, it is absent. Okay. Now, therefore, g dash of 1, if we want to find out, then put x is equal to 1. So 1 into integral from 1 to 1, that is 0. Therefore, g dash of 1 is 0. Now we need to find out g double dash of x. Then there are two functions. One is x square, another is this function. Therefore, integration, chain rule or multiplication rule, x square into derivative of this now. Again, same story, derivative of this, because this is independent of x. First term integral partial derivative term is 0. Second term derivative of x is 1. Put x wherever you have u. Therefore, it is f of x. That is our first term plus, is that right? Plus integral 1 to x f of u du into derivative of x square, which is 2x, right? So that is what is your g double dash of x. Now we want to find out g double dash of 1 is equal to 1 square into f of 1, which is 3, plus, again this integral is from 1 to 1, so it disappears, and therefore answer is 3. That's all. That is how it needs to be solved. Next question. What was this number? 4. Next question, 5. F of x is equal to integral a to x 1 upon f of t dt and integral a to 1 upon f of t dt is equal to root 2. Find f of x. Actually, find f of x is the wording of functional equation problems, but these problems are suitable for this application right now. Therefore, I am taking it. So what you are supposed to find out is f of x. बघा जमतंय का आता? F dash of x. Again, the inside part is independent of x. So first term disappears. This is constant. So third term disappears. Only second term survives, which is 1 upon f of x into derivative of x1. So f dash of x is equal to 1 upon f of x. That is the direct first one-liner solution that we get. So f dash of into f of x is equal to 1. Okay, this information is unnecessarily given. If you put x is equal to 1, you end up getting this. Therefore, this implies f of 1 is equal to root. That is the implication of the second integral quantity. So now this is to be integrated with respect to x. So integral f dash of x, f of x dx is equal to integral of 1 x plus c, and this is easy integral because f dash of x dx, if we take together, then it is f of x. So the integral of that is f of x bracket raised to 2 divided by 2 is equal to x plus c. All right. So if you differentiate this, then you get 2 to cancel, f of x into f dash of x. That is what it is. Okay. Now you have to evaluate c. If you put x is equal to 1, you get root 2 square, which is 2, 2 gone, x is equal to 1, therefore c is equal to 0. This implies f of x bracket square is equal to 2x, implies f of x is equal to actually plus or minus root 2, but then you go back to this condition. If you put x is equal to 1, you don't get minus root 2, you get root 2, and therefore the final answer is plus root 2x. Good. Next problem. Now those who are not able to do it should find out which is the step which is troubling you. If you let me know that, I can help you out. Or you figure out yourself. That is a good way of going about it. Sixth, f is defined from 0 to
f dash of x 1 by f of x कसं आलं?
इथे आपण डेरिव्हेटिव्ह अंडर इंटिग्रेशन वापरणार. ओके, डेरिव्हेटिव्ह अंडर इंटिग्रेशन. व्हॉट डज इट से? First term in derivative under integration is differentiate the given function with respect to your parameter. So this is with respect to parameter x, this is constant, so differentiation is 0. So first term of derivative under integral is gone, 0. Second term of derivative under integral is wherever you find variable, you substitute it with this fellow. Therefore, we have substituted 1 upon f of x multiplied by derivative of this, which is 1. That is your second step. And third step is wherever you see the variable, you substitute the lower limit with negative sign. I mean, that is the third term, which is negative. But this is constant, a is constant. Therefore, derivative of a is going to be 0. And hence we need not have to worry about the third term. So this is the second term of your derivative under integration. नंदन समजले का?
हा सर आता समजलं.
त्यामुळे तो फॉर्म्युला जो आहे तो लक्षात ठेवतानाच असा ठेवायचा आहे, एफ ऑफ पॅरामीटर इज इक्वल टू इंटिग्रल a of parameter to b of parameter f of x comma parameter or parameter comma x. This is not important. Differentiation with respect to variable x. Then f dash of p is equal to parameter. First term, integral, limits as it is. What you are supposed to write here? Partial derivative of whatever function is given to you with respect to parameter. See, after you differentiate with respect to parameter, you should almost get an entire thing in terms of parameter. X should not be there. Therefore, wherever you are going to find x, there is a method by which we replace it with parameter. So this is your first step. You differentiate it and then integrate with respect to x plus second term f of wherever there is a variable, you replace with this upper limit b of p comma p and then derivative of b of p upon derivative of p. That is second term. And third term is wherever you have x, you put a and the derivative of a of p upon d. This is very, very important part. And we know why it is like that because we have derived it also. Now, next one. F is defined from 0 to infinity to 0 to infinity. X integral 0 to x 1 minus t f of t dt is equal to integral 0 to x t f of t dt for every x belonging to R plus if f of 1 is equal to 1, find f of x. Now, these are not easy problems. I mean, we have learned it very systematically and we know the method of going about it, and therefore we are getting the correct answers. Therefore, it is involved. You have to concentrate. Figure out. But then, see, when it is in terms of f of t, these are typical IIT type of problems that I am taking now, where if you know the derivative under integral sign rule, things become very, very easy. Otherwise, it is extremely difficult. It is not difficult integral because the function itself you are supposed to find out. Okay, and you need to know the rule and maybe the basic rules. Here we are doing integral f dash into f of x. What should be the integral? So basic rules. Okay, first thing that you need to do is the given equation that we have, we should differentiate with respect to x. Okay, so LHS 1 into integral 0 to x 1 minus t f of t dt u into integral u into derivative of v plus v into derivative of u. So x, what is the derivative of this function now? This function derivative is 1 minus x f of x because second term will survive. First term is 0, third term is 0, second term will survive. This is the derivative and then why did I write minus 0 here? Is equal to x times f of x. Okay, this is what is the first derivative of LHS and RHS. Now if we simplify it, we get integral 0 to x 1 minus t f dt is equal to, now there is x f of x this side also and x f of x this side also, it will get cancelled. You end up getting x square f of x. Okay. So now again you differentiate with respect to x to get rid of this integral sign and again we have to do the same thing, 1 minus x into f of x, that is your LHS, and differentiate this with respect to x. You have 2x f of x plus x square f dash of x. Okay, therefore 1 minus x minus 2x times f of x is equal to x square f dash of x. This implies f dash of x upon f of x is equal to 1 upon 1 minus 3x. Right? F dash of x upon f of x is equal to 1 minus 3x upon x square. If we now integrate both sides, we should be in f of x. Integrating both sides, we get log f of x integral 1 minus 3x upon x square. This is where you should be really expert. So log f of x is equal to minus 1 by 3 minus 3 log x plus log c, that is a constant of integration. Now if you are stuck at this stage, you might as well go back and revise your indefinite integral. Therefore f of x upon c is equal to e raised to minus 1 by x minus 3 log x. F of 1 is equal to 1. Implies c is equal to e. Okay. Now these are easy things, therefore I am just running through them. The difficult part is already done. 2 times differentiation and 1's integration. Therefore, the final answer is f of x is equal to e raised to x minus 1 upon x whole divided by x raised to 3. That is what is your answer. Any doubts, difficulties? You can ask. Meanwhile, I will write question number 7. Question for today. And this is going to be interesting. F of x is equal to integral 0 to x e raised to t sine x minus t dt. Find wait for some time. Find f double dash of x minus f of x. I mean this f and this is same. F double dash of x minus f of x. But I want a little easier one to solve before this. Therefore, you solve 8th problem first, which I will write here now. 8th problem in blue. F of x is equal to integral 0 to x e raised to x minus t dt. Find f dash of x minus f of x equals. Do 8th number problem first. We will write solution of that and then we will do problem 7. Okay, solution for 8. F dash of x is equal to differentiate this function with respect to x e raised to x minus t 0 to x dt plus e raised to put the upper limit wherever variable is there, e raised to 0 into derivative of last term gone. Now if you observe this term, this is same as this, therefore this is f of x plus 1. Therefore f dash of x minus f of x is equal to 1. Okay, this is problem number 8. Now in problem number 7, I think there is little caution that we have to take. Because this, whenever this x minus t becomes 0, we might be in little trouble. I mean, we will try to find out when we are allowed to do this, or what is the bypass for that. So here what I will suggest is use this property of definite integral 1. Which property? Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Try to use this property first and then deal with this integral. That is my suggestion. Why should we do that? Maybe we will try to search the answer in the next lecture. But at the moment, if you straight away go and differentiate it with under integral sign rule, you might go a little wrong. That is what is my feeling, because you end up getting two different answers by these two different methods, and therefore whenever some bracket, actually this bracket also becomes 0 when you put x is equal to t, but it is not making any difference as far as the final answer is concerned, but here it makes difference. So therefore use this type of formula first, or maybe I think second way of going about it is you expand sin x minus t, sin x cos t minus cos x sin t, and then deal with it. Again it will be correct. Try to do that. Okay, now as far as problem number 7 is concerned, if we directly apply Leibniz to this problem, we get some answer. And if we apply this property of definite integral first, followed by Leibniz, we get some other answer. So we need to figure out why these two answers are different, which we will try and do it in the next lecture. But then I am going to give you one more problem, problem number 9, which will give you similar kind of experience. F is defined from R to R. F of x is equal to x square plus integral 0 to x f of x minus t e raised to minus t dt. Find f of x. Here also this factor x minus t is inside integral, and therefore I really do not know whether we will be able to get correct answer directly or not. You try it and let me know. Okay, spend time on these problems. Try to do it in a couple of ways and check whether the answers are same or not. We will discuss these two problems, 9th and 7th, in next lecture, followed by some interesting applications. That is where we stop for the day. Thank you.